Globular clusters, as ancient as the galaxy itself, constantly lose stars that drift away and join the general stellar field of the Milky Way. It's quite possible that these escapees significantly influence the galaxy's halo. If a star left its parent cluster long ago, its origin can be traced by analyzing certain chemical composition markers, such as nitrogen abundance. In a recent study, a team of scientists aimed to establish dynamic connections between nitrogen-rich stars in the Milky Way, recently identified by the LAMOST survey, and existing globular clusters in the Milky Way. By analyzing the characteristics of proper motions along with metallicity, they managed to identify 29 potential parent clusters for 15 nitrogen-rich field stars. Some of these stars may even be linked to accretion events in the Milky Way. On the other hand, if a star recently left its globular cluster due to tidal forces, it still retains the kinematic properties of that cluster. Based on spatial location analysis, proper motions, and positions on color magnitude diagrams, more than 1,600 additional candidates were successfully identified near 6 globular clusters. The spatial distribution of these additional candidates confirmed the effectiveness of searching for structures beyond the original birthplace and pointed to the possible presence of long stellar streams. Among 95 additional candidates with spectroscopic data on radial velocities and metallicity, 54 were confirmed as globular cluster escapees, as they share similar properties with their parent clusters. These additional candidates are ideal targets for follow-up spectroscopic observations. Once a statistically significant amount of spectroscopic radial velocities and metallicities becomes available, the dynamic evolution of globular clusters, including mass loss, rotation, and evolution over time, can be carefully studied. This, in turn, will provide insights into the evolution of our own galaxy.